Hi, this is Synthchaser with synthchaser.com. Today I have the absolute honor of being able to restore this ARP Pro DGX for a legend in the genre of funk music. I had the opportunity to see him in concert a couple weeks ago, and I see why he's the legend that he is. And so I'm honored to be working on his Pro DGX. This one is in very sorry looking condition. They told me that it was cannibalized for parts for one of their other ARP Pro Soloists or Pro DGXs. I can see the bottom panel is missing, and it's kind of just secured together with this tape. We got broken switch. The high C is missing. It looks like it's actually cracked off. So I'm going to open this up and we'll see what other parts are missing inside. So right now the synth is just held together by foam and bubble wrap and tape. So we're going to open this up and see what we have to work with. Let's carefully peel this back. Hopefully it doesn't take off any paint, and it doesn't. And let's see what we've got going on. Whoa. So the key bed is not secured here. So what I'm actually going to do is I'm going to flip this over. Normally to service these you would have it on its back, and let's get this off, and then you'd remove the wooden panel from the bottom. So I can take all this stuff out of the way, and let's turn it around and have a peek. So this is an earlier Pro DGX. Inside, the case style is very similar to the Pro Soloist, where you have to access it from the bottom panel. I've done other restoration videos of Pro Soloists and Pro DGXs. The Pro DGXs that I did in the videos were the newer model Pro DGX with the hood that opens up, like a later style ARP. Looks like there's a note in here for me. I will have to take a look at this. But it looks like all the boards are here. Let's see if there's some ROMs seem to be coming out of the sockets, so I don't know. I'll have to take a look at this. But basically what we're going to do is we're going to do the same type of restoration that we did in the other videos, so I'm not going to go into so much detail. But basically what I'm going to do is I'm going to take all the boards and parts out of the synthesizer. I'm going to recap everything, and I'm going to set it up on the bench and test it to make sure that it's working. I'm going to change the sliders out with the cool LED sliders to make this instrument as bold as the musician who it belongs to. And I will show you what I run into along the way. It's never a good sign when you open up a keyboard and there's transistors sitting at the bottom of the case. Also, I can see that this power supply, the connectors are kind of all mangled up there. So let's pull this out and see what's going on. At some point, someone either cut or broke one of the wires connected to the quick connect terminal on the power supply. So then they just soldered the power cord directly to the power supply board. So I'm going to remove this, and I'm going to crimp new quick connect terminals on so they can connect to the board as intended. So I've got all the boards out of the synthesizer and took a quick look over them. This is board A, the waveform generator board, the board with the sliders, and we're going to change out these very dirty sliders with the LED ones, and we're going to recap the little blue and red blob tantalum capacitors. This is board C. It's the board with the filter. So this, like the Pro Soloist, uses the 4034, the encapsulated submodule. Here I noticed some pretty nasty looking rework there, and this chip's kind of smashed. So I'm going to take a look to see what should be going on there, and also when I recap these I'm going to take a close look because I found a transistor laying in the case. I want to see if it belongs somewhere in this synthesizer or not. This is the voice selection switchboard, and it's intact with the exception of one switch, and I should be able to source a replacement for that. This is the touch sensor board, and it has a cracked, broken switch here. And unfortunately, the white switches aren't available anymore. So if you need a white switch, you have to pull it cannibalized from another ARP synthesizer. I do have black replacement switches available, but that would kind of stand out like a sore thumb. And because I would just be honored to take one of the white switches from my ARPs and put it in this one for my customer. This is the envelope generator board, board B, and this is where I mentioned I saw ROMs sticking out. So I'm going to make sure that those are the correct ROMs. Any socketed chips, I'm going to make sure that they're correct before I plug it back in. The keyboard electronics board is under the keyboard. I took a look at it. It looks okay. The bus bar looks very dirty. And someone wiped the keys, but you can see how filthy they were. The part that you can't get to is still dirty. So I'm going to take all the keys off, and I'm going to wash them and clean the bus bar, adjust the key contacts. Also, the touch sensor bar is under here, and I'm going to take that off and rebuild that with a new touch sensor. Over here we have the power supply. There was some damage here when I desoldered the power cord. This one quick connect jack terminal just came off, so I'm going to put it back and then crimp quick connect terminals on the power cord, and then go through and recap this and make sure it's working well. So rather than take the switch out as I did in the previous video, the switch and the power cord, I'm going to repair this and then put it back into the case, and just for future testing we'll have the power supply in the case. And then for the jacks, in previous videos I've taken the jacks out of the case. What I'm going to do here is I'm just going to wire my own 1/4 inch jack to these wires, because there's these are soldered to the board, so I'd rather desolder from a jack than from a circuit board if possible. So then I should be able to recap this and get it set up on the bench, and we'll test it out. Here's a look at the keys before I wash them. Pretty gross looking. So these are the key levers, and you can see this is where they were covered with the white and black keycaps, and this is where they were exposed. So they're really dirty and grimy here, and I'm going to clean these as well and then dry them with some compressed air so they don't rust. I want to make sure that this stuff doesn't get back down on the cleaned bus bar once we're done with it. I took a look at the circuit board that I noticed had some damage to it, and it looks like there's one broken resistor here and a missing transistor here. It's a 2N5172, which is just a regular NPN transistor, and I'm going to replace that with a 2N3904, which is about the same specifications but a better quality transistor. This is for the pulse amplifier, so if this section is out, that would explain why much of the synthesizer wouldn't be working. So I rebuilt the power supply, and I changed all the capacitors, the tantalum and the electrolytic capacitors, and I repaired the wiring and the quick connect terminals and tabs. I crimped new quick connect terminals to the power cord wire, and then I also discovered that the spade terminal that connects the ground wire to the case had been cut and just soldered back together. So I cut that section off and I crimped a new spade terminal there, and we're ready to fire this up and make sure that it doesn't blow up. So I've turned it on. I made a video in the past on how to test ARP power supplies. This early model Pro DGX uses a different color scheme for its power supply than most other ARPs. So the 15 volt rail's at 15.24, and that's fine because there's no load connected. The 5 volt rail's at 5.20 volts, which is fine. Again, no load is connected. And the minus 15 rail is at minus 15.02. So it checks out okay. It didn't catch on fire, and that's always a good sign. I'm kidding, I've never had one catch on fire. Not after I've worked on it. I've had them catch on fire before I worked on it, but not after I've worked on it. So now what we can do is we can turn this off, and all the other boards that I recapped, I'm going to connect them on the bench, and we can assess the condition of the electronics of this synthesizer. So I've connected all the boards on the bench. The Pro Soloist and the early Pro DGX are kind of a pain in this regard because you can't surface the boards and poke them with an oscilloscope once they're installed in the case. They're inaccessible. You can't just pull one board out either. You got to take the whole mess out. So I've set it all up here on the bench: touch sensor, keyboard, power supply. I soldered on a jack and connected all the boards so we can fire it up and see if it works. So the LED sliders light up, which is a good sign, and I'll pick the first voice here, which is bassoon. And it seems to work. Let's try the next voice. That makes sound. Next voice. That makes sound. So this is clarinet, and it seems to be stuck on. This is flute. It seems to be dead. Also dead. Also dead. Also dead. Also dead. Stuck on. Stuck on. Dead. Okay, I get the idea. So some of the voices seem to work okay, some of the voices are stuck on, and some of the voices are dead. So let me go grab the schematics and we'll have a look at this. So I grabbed the oscilloscope, and for troubleshooting problems with the Pro Soloist and Pro DGX, there's this handy voice flow chart that shows you what waveform should look like on the oscilloscope at various different test points. It also shows you a picture of the routing of the signal through the synthesizer. And bassoon, this voice here, was one that worked. And clarinet was this one that I have on now that's stuck on. Something being stuck on screams of an ADSR envelope issue. And from looking at these flow charts, what I can see is the bassoon voice uses the attack-release envelope generator, and the clarinet uses the ADSR, which has a decay and sustain. So that first test point that I'm going to want to check is the ADSR output. I want to see that that envelope is being generated correctly. So for that, I am going over to the schematics here. And the output of the ADSR is on the emitter of transistor 4, Q4. So let's hop over there. This is on board B, which is the envelope generator board. So this is the emitter, and we've got 7.8 volts. Which isn't changing when I press a key. So, as I suspected, the ADSR is stuck on. So let's go and make sure that we have the correct signal coming into this board. So, looking at the schematics here, there's a gate input that comes in on connector J4 pin 6 and goes into pins 12 and 13 of this IC. So let me just look on the IC, pins 12 and 13. So this is the input, the gate input. So I'm going to press a key. So the gate input is correct. So then it comes out, it's inverted by this, this NAND gate. It's inverted here, and then it's inverted again and split into two places on this other chip, 7403, which is also a NAND gate. So let's look at the output of the first NAND gate, the 7400 IC. So this is pin 11. So it's high, and then when I press the key it goes low. So that's correct. So then let's hop over to the next one. I'm going to look at the output of the second NAND gate. So this is pin 6. So this should be a positive going pulse when I press a key, and it's not. Let me look at the other one, which is pin 8. So this is the same chip, and this second line is working. So one would normally assume at this point that this chip is bad, but this is an open collector TTL IC. So basically, if there's something on the output of this that's pulling this down, that's a possibility. So I'm not going to assume that the chip is bad, because the chip is working for one of the gate outputs, but not for the other. So let's see where that one goes. It's this pin 6, and it looks like it comes down. It splits 2 paths. It comes down here, right over to the output section of the ADSR. The other one goes through these other NAND gates, comes across, goes through just some passive resistors and diodes, and back to the same place here. So these 3 transistors are what I would suspect possibly has a short that's pulling this open collector output down. But let's poke around on the transistors and take a look. So, well, so here I'm just touching one with the lead of the oscilloscope, and it's making a change in amplitude of the sound. So what I'm going to do is I'm going to take a look at these transistors and see if they might be the problem. One other thing I'll mention is the ADSR not working might also explain why voices are completely dead, like the flute. Some voices take the ADSR envelope, invert it, and pass it to the voltage controlled filter. So if there's a invalid control voltage being passed into the VCF, there could be no output, and that could cause a voice to be silent. So we are going to just focus on this issue right now and get it resolved and see if that resolves the issue with the other voices. So what I actually found was the minus 15 volt rail was completely missing from that envelope generator board, and I traced the break back here to this connector at the bottom of the keyboard. Of course, this side is soldered directly to the board, so it's not just a simple matter of changing the ribbon cable. You'd have to remove this board, take all the key contact things out, and it would be a big mess. So what I did is I took the connector apart, and I see here where the wire is broken on the cable, and I'm going to try to repair it and see if we can bring that minus 15 volt line to the envelope generator board. Brought the minus 15 to the board B, and this one was working okay. This is the one that wasn't releasing, and it's still not releasing. This one we had no sound at all, and so we made a little bit of improvement, but we still have some issues to track down. To show that I made some progress here, I now have the oscilloscope hooked up to the base of this transistor Q4 here, and previously this was pretty much at ground no matter what you did, but now you can see that the envelope appears on the base of this transistor. But unfortunately, on the emitter, which is the output of the ADSR, oops, I moved off of it. It remains stuck. So now I'm going to look at this section with the transistors again and see if I can figure out why. And I found the problem at last. This precision resistor here, it looks okay, but it's actually, the lead is cut. So this lead is not soldered to this pad. And that's going to be our problem. So now that we repaired the broken connection between the keyboard and board B and the broken resistor on board B, Let's run through the voices again. And then here's the ones that was stuck on. Here's the one that was dead. So it looks like we have all the voices there, and they sound pretty close to what they should be. I mean, the unit needs a calibration. But the next thing that we need to test is to make sure that the other functions of the synthesizer and the touch sensor and all that stuff works. So that's what we'll do next. So with everything finished and working and the keyboard reassembled, I started to put everything back inside the case, and that's when I noticed that the brackets that hold the key bed into the case had been sheared off and were attached to the key bed. I took one of them off here. You see it fits here, and this is where the key bed screws in. It rests on here, it screws in. Unfortunately, there's this 90-degree angle of like 1/16 inch thick sheet metal, and it doesn't hold up. I've seen them cracked off before, but never on both sides. So what we're going to have to do here is we're going to have to install some standoffs. We're going to have to drill a hole in the case and install a standoff basically to secure this key bed into the case. So I managed to get the key bed reattached securely, and I'll turn this around and lift it up, and you can see I've also installed the bottom panel that I custom made for this, along with feet for the instrument. So everything is all nice and closed up, and I'll turn it on. I ran you through the upper voices. The lower voices work too. The touch sensor effects are all working. So pitch bend, I'll make it most sensitive. Wow, growl, brilliance, volume, vibrato, and repeat. I'll pick a voice that you can hear that better on. So it's all finished and ready to go, and hopefully its owner can put it back to good use and make some more albums with it. This is Synthchaser from synthchaser.com. Thanking you for watching. If you have any questions, please post in the comments. I sell parts and offer repair service on my website, synthchaser.com. So head over there and check it out if you're interested. And thanks again for watching. Bye.